Welcome back to our statistical learning session. Today, we'll be talking about p-values. When we talk about p-values, we have to talk about cutoff. Cutoff is a real thing, as we discussed in our last lecture, where we had a cutoff C. Where does cutoff C come from? Cutoff C is equal to Q alpha. And what is this Q alpha? Q alpha is a Z value that is equivalent of particle alpha. And alpha is a area under curve, AOC, area under curve. And alpha is the probability of making type 1 error in the test. Now, let's say alpha is 5%. What a Q value Q alpha is? Do you know? Q alpha is 1.645%. So 1.645 is a Z value on the x-axis of the normal curve. Wouldn't it be nice if Q alpha was living on the same space as alpha? Then it will be easier for us to ask questions such as, will I be still rejecting null hypothesis if the alpha was at 1% or 10%? In that case, I wouldn't have to do a calculation and test again to answer those questions. And it also make our life easier when we don't know the Q alpha value of Q alpha at 10%. Do you know the value of Q alpha at 10% by heart? I guess you don't know, and I don't know either. So let's jump to the p-values now. When we are doing some calculation of the TN test statistics, when you start do some so when you read some study and it gives you some conclusion such as this percent of people turn their head on left or right, and it gives you some verbose conclusion, and also in addition to that, it also gives you some numerical conclusion. It's not a value of test statistics, it is a p-value. Why do people report p-value? People report p-value in a study paper because it lives in the same space as alpha, and it helps to answer questions such as, would I be still rejecting the null hypothesis if I did this test again at 5%, at 10%, or at 2%? When we are doing test statistics, the cutoff lives in a space of z-score. But the p-value is the area under curve which lives under between, which is a space between 0 and 1. Now let's go to the definition of p-value. P-value is a value of test psi alpha. It is the smallest level. So p-value is a level. It is alpha, and it is the smallest alpha for which psi done at test alpha rejects H naught or null hypothesis. Do you understand what I mean? So for example, as alpha increases, the more and more I reject, and as alpha decreases, the less and less I reject. And when alpha is becomes 0, I stop rejecting at all. So somewhere between 0 and 1, there is a cutoff that we are looking for. And this cutoff is where when alpha keeps going down, and there comes a point where the alpha is equal to the alpha, which is equal to the smallest alpha at which we can reject h naught. If you go below that alpha, then you are not rejecting h naught anymore. So it is that alpha where you can still reject h naught or null hypothesis, and that's the alpha we are talking about, and that's how we get the p value. It is actually alpha, and they both live in the same space. So golden rule is that we remember that p value is small, less than alpha, then you will reject. If p value is less than alpha, then you reject. That's a golden rule to remember, and is bulletproof. Now let's give you one more example. Let's say p value is 0.5%. You can afford to reject null hypothesis at 1%, 2%, 5%, etc. Now question arises. How do I remember that I want to have a small p value? We can remember by saying that having small p value means rejection. P value being small means reject. That's how we can remember. Small p value is equal to reject. When p value is, let's say somebody gives the p value as 0.01%. Not only does it tell me that it is really small value, but also tells me that how confidently I am rejecting null hypothesis. It gives me confidence that I can reject null hypothesis as 1%, 2%, 3%, 4%, and that is that we say, and that was what we call about p hacking by John Oliver. This is what we mean. In the end, let me quickly summarize what we learned today. We learned about p value. P value is the smallest alpha where we can still reject null hypothesis. If we go below that value, then we are not rejecting null hypothesis anymore. P value is useful in a sense that p value lives in the same space as alpha, and it gives information about whether we can still reject when alpha is 1%, 2%, 3%, 4%, 5%, etc. And having smaller p value, it gives more confidence that we are rejecting null hypothesis. That's all for today. I will see you in next learning session. Thank you so much.